So good afternoon, everybody. My name's John. I'm here from Looker, of course, one of their enterprise consultants, and here to talk about how we see the future of BI, which is actually a slight tweak, which is not just a BI tool. You know, business intelligence stays relevant and will be for the foreseeable future, but it is not the only way that data is being used. And in this context of data ops, it's not the only place that analytical data tends to end up. It used to be you would have a warehouse and then you could have dashboards against it, but there's a lot more happening these days. Brief introduction to Looker as a company. So that's our mission: empower people with the smarter use of data, however that might be. We're about 900 employees these days. We started in 2012, so we've had a nice rate of growth. We have 2,000 customers. Around half of them, that 1 in 2, is using them for non-dashboard purposes, if you like, or non-traditional BI use cases, hence the subject of the talk today. And on top of that platform that is Looker, we have about 5,000 developers amongst our customers. And we don't think of it just as analysts working on data, but also developers building applications. We see, from our point of view, there's 3 big trends in the market that's driving this idea of, where's business intelligence going in the future? First of all, this fact that everyone needs data, like the number of people or the proportion of data, people within the company that want to make use of data, and preferably, fresh, live, and accurate data, is significantly higher than it has been before. The sources of those data are changing significantly as well. This proliferation of SaaS applications. If you just think about how many applications you might have used just coming here today. Certainly, although this is now a PowerPoint presentation, I use Google Slides to put this together. I've used Expensify to do some of my travel costs. We're using Salesforce in our company for CRM. And in all these cases, it's a big change, or at least over the past 5-10 years, that the places that are storing the original records for these data are no longer on-premise. They're no longer internal systems. They're these external applications that quite possibly, you don't want to figure out from scratch how to integrate with. And finally, infrastructure has evolved. There is a significant difference in what is a modern data stack these days. So we are here today. We have a joint stand from Snowflake that just did the previous talk. So there's big changes in the way that data can flow through your organization and be processed. So we think those are the 3 big trends. And it does drive a lot of why people buy us and how they implement us. So digging in a bit, trend was this: everyone needs data. I'm not going to spend too much on this. You must be aware that there's an ever-increasing volume of data. But that's a good starting place. The scale of data is significant. Multi-petabyte, tens, hundreds of petabyte data sets or data warehouses is not unusual anymore. So there's the sheer scale of data that we're expected to cope with. But what's perhaps more interesting from Looker's point of view, is the kind of bit where data in a warehouse starts turning into value, is that the expectation of data, even at a consumer level, let alone the employees within your organization, is transformed. Just shopping. We're expecting live updates on the status of our packages being delivered to us, for instance. And that is live operational data that no longer fits in the world of the warehouse is up to date as of yesterday. These are things happening today, during the working day. And, we expect this data as consumers to be available in our pockets. 3 of our customers, as happens here, who have applications. So whether that's Deliveroo or Venmo doing mobile payments, these are providing data streams, quite possibly billions of events during the day. And this is data that is actionable from the point of view of these companies. And it's data that the employees would expect to be accessible to them as well. And the big difference there being during the operational process, not as a historical event that they look back on. And that has resulted in a modern data workforce that is data hungry, as we call it. The expectation is that if you're going to be a data-driven company, it's not what we often encounter, which is someone says, well, yes, I am very numerate, I'm a good analyst, or I'm quite senior. I used to be maybe in an analytical role. Now I'm a senior manager, I still consider myself quite quantitative. So as long as you can give me a spreadsheet of data, I consider that being data-driven. And we think, well, that's probably at least a day old, quite possibly a week or month old, and that is not really being data-driven. Data-driven is about figuring out how to run a better operational process and being able to take action on the data as it comes in. And there's various figures out there for being data-driven is a good idea. Now, if you look at the way things used to be, that's not new. So, for instance, Walmart, as a retailer, has long been extremely good at large-scale data. But they are now using us to build applications on top of their warehouses, custom applications, not business intelligence tools, for instance, for store management, for inventory within their retail stores. So although it's not new wanting to be data-driven, the boundary of what's possible and what is necessary to be competitive keeps on expanding, resulting in, well, in this case, Deliveroo, one of our joint customers with Snowflake that was just presenting before. And this is a great example of genuinely data-driven. The little gadget on the guy's arm there, he is responding to orders coming through. Individual restaurants who are not part of Deliveroo as a company, they are essentially partners with them, and they are getting live updates on what recipes or what meals are performing well. So this is very much a part of the operational processes of these challenger businesses. And whether you're a new company, a challenger into the marketplace, a disruptor such as Deliveroo, or you're part of an organization that is wanting to keep up and stay relevant, this idea of being data-driven does flow into the speed of the data movement. And what's particularly interesting about this case, and why I've got this one up on the screen today, is if you have that data-hungry workforce, that means lots of people wanting to access that data at once. That means concurrency is your technical challenge, and Snowflake and all the new cloud data warehouses are a strong part of what makes that possible. If you take a traditional data warehouse and throw 1,000 queries at it from different places, there's a very high likelihood it probably won't fall over, because we knew how to build things reliably, but it is probably going to run slow. So the massive parallelism that you have access to, Snowflake's one of our favorite examples of that, means this idea of being data-driven at the workforce level during the operational process becomes possible in a way that it wasn't before. Proliferation of SaaS applications. So there's that question. How many have you used today? Probably a few. Probably in your company there are hundreds, if not thousands, of SaaS applications being used. And these are providing essentially competition to the BI dashboard. If you have a relatively modern application, and especially the SaaS applications, it will have a data interface most likely of some kind. And it might have something that you can use in the palm of your hand. I mean, I certainly have that through some of the applications we use. And what we think the key thing here is that this is, this data in the palm of your hand or on your screen, this is data where the user is, in the user workflow. Dashboards are typically not in the user workflow. We have dashboards, we do ad hoc data queries, but again, not usually as part of the data workflow. That's a BI use case. And there's these new examples showing up. And the growth in SaaS applications is huge. And the output of that is a slight problem, which is that we have these islands of departmental data. So Salesforce is a great example. It's an extremely well-adopted platform. It does have analytical capabilities within its own space. But if you're trying to do, for instance, a 360-degree view of the customer, and you have behavior data of some kind. So for instance, not just that they are a customer, not when they signed up, not how much revenue they've generated or what subscription they have with you, but also here's what they're doing today, here's what they were doing yesterday, here are analytics, KPIs around renewal rates combined with other data coming out from transactional systems. Having all of these separate views of the data is a problem. And according to Forrester, anyway, and we certainly see this when we're talking to customers the first time around, as much interest as there is in, let's say, the data lake approach of capture the data and then analyze it, actually most structured data, let alone unstructured data, isn't analyzed in the first place. So all of these changes, the pace at which things are moving is kind of getting ahead of most organizations' ability to respond. And that's revealing itself in this particular problem. And another partner we hear today is Fivetran that's helping us solve this, is that the traditional approach to wrangling data doesn't work. A lot of analytics is done in what we call workbook analytics tools. And I'm not really going to just go through a list of competitors or anything like that, but think of the Excel spreadsheet and perhaps a visualization layer on top of that. The problem with having thousands of these spreadsheets floating around is it's almost guaranteed that that will not be live, fresh data. You know, it's some extract someone's got from somewhere, and then you go into a meeting with a room and someone else has their spreadsheet that they've got from somewhere, and in theory you should have the same number of customers, revenues, faults, failures, clinical cases, whatever it might be, but actually each workbook has managed to come to a slightly different answer to something that should be a core metric. When we started at Deliveroo, they had not that problem. They did have their data in, I think it was AWS Redshift at the time, but what they had was thousands of different SQL queries. So people had their way of getting this data out, but it was handwritten, difficult to maintain, difficult to change. WeWork, they had a relatively small data team. This is pretty common. You know, you probably only have a team that size. You know, they had, I think it was 2 to 4 people doing, trying to do the analytics for a company with thousands of employees, and you just can't scale that if you're trying to do these workbooks or these snippets. And where it comes a problem with the SaaS applications, it's a difficult and complex thing to start from scratch, getting data from a Workday, for instance. You know, so this traditional approach that every time there's a pipeline to go into the warehouse is something that's the responsibility of the engineering team to build, just absolutely does not scale. If you've got hundreds of apps, thousands of applications, and maybe even just 10 of them are absolutely pretty critical to your business, like the CRM tools and the HR tools and so on, you know, trying to build your own doesn't work in that environment. And this is one of the reasons why the stack that we are at here today, which is Snowflake as the warehouse, Fivetran as the pipeline, and ourselves as the analytical layer on top, is that we've got a good solution to, you know, if you need a custom pipeline, that's great, but for a lot of your requirements, you know, let's avoid all of that. You know, let's reuse an off-the-shelf tool for existing things. And that's how we get into this question of how can we create a data platform that is serving the whole organization. So the hope is coming from this trend in data infrastructure. That's the 3 I just talked about there. So databases, Snowflake, BigQuery, Redshift, you know, these separations of cloud and compute massively parallel. So you can have vast quantities of data. It's not a problem to suddenly create a new warehouse, essentially, or a new virtual warehouse, because you're only paying for the storage. It's relatively cheap. So suddenly, the idea of having a common platform for your data, whichever one you go with, is possible in a way that really wasn't before. Moving away from pipelines that used to be extract, transform, and load, the flip around to that, extract, load, transform, is a simpler way to do things. So for instance, if you wanted to get started with Salesforce and you wanted to run analytics combined with other data, so it now needs to be outside of the Salesforce environment, Fivetran could quite easily pump data into Snowflake, and you could have an initial model, including an out-of-the-box model for us, within a day, without any problem at all. We do it as a matter of course. And then on top of that, for all of the talk of NoSQL, of shaking things up, and the big data revolution with Hadoop, actually it's turned out SQL remains the analytical standard. It is the language of data analytics. Everything these days will have some kind of SQL interface. And these are the 3 pillars of the stack that we are here talking about today, with ourselves, Looker, forming the piece that generates the SQL. So the cloud warehouses, stable, low cost, ease of use, you know, the ability to dump that data in and start making use of it across thousands of users is transformative. And this is the usage that we are seeing through our platform. So Snowflake there at the highest rate of growth at 213%. Redshift, AWS being the most established player, and this having the bulk of our customer base. Also, we're seeing a lot of things like Postgres and MySQL. So in other words, product lines or products that have got a digital way of doing things. So the most popular open source databases often deployed to the cloud. This is what we are seeing in the market. And of course, the big players, AWS, Google, and Microsoft there, seeing big uptakes. We are watching this shift from on-prem to cloud happening. So what do we see, taking those kind of three trends and those pillars on which we're basing it? So what is the future of business intelligence? Well, there is still classic BI, but what we're finding useful is to talk about it in terms of we're doing data experiences these days. So a dashboard with a drill down into an ad hoc query is one example of an experience, but I shall touch on some others. Now, to get into what's actually built into the Looker platform. So we start with the idea that you will have data in many places. You will have your own transactional systems, almost always. You will also have large number of SaaS applications. You will also be using services, say in the ad tech space, you'll be using Google, Facebook ads and so on. So not so much SaaS, but digital services that spew out significant quantities of data. And you centralize that in essentially the modern data lake, which these days is actually going back to the idea of a data warehouse. So data warehouses now, they will handle semi-structured data. You can handle JSON records, you can handle documents, but you can still get all the value of a relational model for analytical queries. So that's not us yet. That's the bottom of the stack. And our partners here today for that are Fivetran and Snowflake, and we work with a variety of others. And then the Looker Data Platform sits on top of that. The core of it is a Git version-controlled data model. So back in the day, MicroStrategy, Business Objects, Cognos, they proved out the value of having a semantic layer, something that describes the data that you have in your warehouse. The problem with those ones was it would normally take weeks, if not months, to have a change. So if you wanted to bring in a new data source, there would be a requirements gathering process, possibly a prioritization process. Is this data worth getting into our warehouse? You would then design the process, the pipeline by which the data got in there, and then eventually at some point you get into an actual output. And you could think of that, if you compare that to application development, also went through a similar process. There was a weeks or months long process by which happened. With the new tools that are available, because we're using Git, we haven't invented the idea of continuous deployment or Git version control, but we do take advantage of it. So we can put changes out into the data model on the same frequency that we do with modern SaaS application development, which in other words can actually be several times a day. Small incremental changes that are easy to test, easy to roll back, and make it easy and fast and agile to build out this data platform. The core part of which is just an understanding of the data, not just the data that you have, but the KPIs and possibly the multi-tiered SQL queries that you get your final KPIs out of, provide some governance around that, provide some best-in-class APIs, have all of it accessible via an API, and you can start building these data experiences, as we call them. And we see three main ones at Looker. One is just modernized business intelligence. So taking the Home Depot example there, for instance, they moved from Splunk, so they were using Splunk and the machine learning, or the machine intelligence, as they call it, for running security. Actually quite an expensive model to work, because you're paying for the amount of data that's being stored. So they moved to a combination of BigQuery plus us. So we're providing the model that's looking for the patterns, the anomalies, to trigger alerts and pages and so on. And we're using BigQuery under the hood for the fact that we can now store vast quantities of log data without actually incurring a bill, because the log data is relatively cheap to store. And that for us is an example of just modern business intelligence. The pipeline is fast, the data quantities are potentially massive, so we use separation of compute and storage, we use a version controlled modeling layer, to provide actually quite a standard business intelligence experience on top. Another category is this infusing workloads of data. We talk about this as being, don't think of the dashboard as being the end of the process. It very often is in the data space. It's just like, we got the pipeline, got it into the warehouse, built the dashboards, that's now up on a screen or it's being scheduled out as report packs. The job is done. We think it's slightly different, which is once you've got there, ideally, in a data-driven company, that's the start of the process, because you've only just got started on actually turning this data into something useful. Really interesting use cases, this company, Future Play. So they are essentially doing mobile games. So a big part of their business model is how do they get new customers? Customers come in through advertising, through Facebook ads, through, I think they use about 6 different ad networks. And on a regular basis, you have to choose how much you're willing to pay for a given keyword to get an ad on a given network. So the question is, well, how much is that worth? If I'm going to spend £1 on an advert, presumably it's because I think I'm going to get more than £1 back in terms of revenue. So they have an overall flow. The data, their operational data in their warehouse is one of the things that we combine with the outputs of the Facebook and Google ad networks. So some of it is their data, some of it is these well-known data sources that they've just piped in automatically. That's stored in the warehouse, and that forms the basis of your standard business reporting. Here are your KPIs, here are your revenue trends, here are your customer segments and how well they're performing, which is all valuable. But to that question of how much is an advert worth to you, how much is a keyword worth, they use Python machine learning processes, so they're doing forecasting 30, 60, 90 days against each keyword value. So that is done, as it happens, that's done outside of the Looker model, but it is used to enrich the Looker model. So now they have the campaigns they want to run, the networks, the keywords, and they have a predicted value against that. And because we're not just BI, but we're also API driven, they have a fully automated process from there. The bids for those ads are placed onto those networks via an automated process. And the output of that, the success of that, is what's monitored. As compared to the more traditional way, which would be if you have a data source and then you make your predictions, you then end up with a spreadsheet and somehow you get that spreadsheet loaded up into the purchases that you make. That is a fully end-to-end automated process. And that's the start of, this is why we say the future of BI is not just a BI tool. You still want to report against the performance of your business, but now we're using that same data to feed a predictive model that is being used during the day to make decisions, in this case placing advert bids. And then finally, the third kind of broad category of experience that we talk about is this better data products. A couple of interesting examples here. Global Payments is, they handle credit card transactions for companies as large as Walmart and as small as, the American term is the mom and pop shops. People who are not necessarily financial experts, and yet the transactions are key to their business. So we are embedded into their online application. They like us because they have a lot of customers. So they need a couple of things. They need consistent data across all of those. They can't be doing a new workbook per customer, and they can't have a process whereby if an error is identified and they want to change things, they need to do an automated rollout. So that's what the Git version control process drives. And we're also providing absolutely reliable security to that. So any query against their data that's showing up in the app should only be the data for that particular customer. So that's kind of what our platform layer is providing. And then at the front end, they have their own custom-built application. This is the user experience they're providing out to their customer. But the components within that are a mix of things. Some are complete dashboards from Looker, just straight out of our application. In other cases, they have a particular user experience they're trying to get. There are specific buttons they want to see on the screen. They want a user interface that fits their brand. So they don't want to embed. They want precise control over what's showing up. but they don't want to figure out how to do a data query engine. So they use the fact that we have an API coming out of this platform, as well as the fact that we can do traditional business intelligence. And namely there is a similar example. So they're in the HR space. And again, they don't want to figure out how to do analytics. They want to figure out how to do better HR. They're also using a variety of techniques, embedding and using the API. But that's the ability to build a new data product and to have a stack that from start to bottom can all be managed by essentially a modern application development workflow. Very different thing to your traditional analysis workflow, and feed their front end with data that's coming through us. So those are examples of the data experience, what we mean by it. And just to dig into a little bit into the Looker technology details, although please come and see us at the stand if this is interesting, is first of all, we are an in-database architecture. That means aside from a use of a few caching techniques for responsiveness at the front end, we don't move data out of the database. If you take a lot of tools that were written in the 90s, early 2000s, you'll start topping out. It can be as early as 5 or 6 gigabytes of data. That's the limit of what you can fit into that particular workbook or spreadsheet or model. We'll happily cope with tens of petabytes of data, and actually not because we've come up with that solution, just because we integrate extremely well with the databases that, because of the parallelism available today, gives you significantly better price performance. We have a semantic modeling layer, so that's the thing that provides consistency, gets away from having thousands of spreadsheets and just answers. No, we'll have a model that everything comes through. You can then generate 1,000 dashboards if you like, but we're going to provide a guarantee that the data that's in them has come through a model. And then finally, this API-first extensibility. It really is, you could say we're just taking advantage of the fact that we're a relatively young company starting 2012, but the idea of having everything available through the API really is quite significant. If you are building an application experience, people often talk technical versus business, but if you are technical in the sense of, I understand my business, and I'm an expert JavaScript developer, and I build fantastic and scalable applications, and I know what SQL is and I can use it, but I really don't want to have to figure out how to do a complex schema design and turn that into a query. Okay, well, let's give you an API call. Just tell me the data set you want, the 5 or 500 columns you need to take out of the data. We will translate that into SQL for you, and you can drive whatever experience it is that you're wanting at the front end that way. And finally, our multi-cloud strategy. All of this lives on the cloud provider of your choice. So we started on AWS, as so many companies did. We're rolling out on GCP as well, which is good because Google is buying us, so it's nice to know by the time they buy us, they'll also be supported in their environment, and we'll be rolling out support for Azure during the first half of next year. So have your data wherever you want it to be. Once it's there, don't move it. Query it, build it into a workflow, turn it into an API that feeds an application. But data is heavy, especially when you get into the data sizes that we have these days. Stop trying to move 50, 60 gigabytes around at a time just to do some little thing. Leave the data where it is and use the engine that is Looker to get that data to you. And then finally, you'll be pleased to know I am not going to go through this slide in detail. This is our architecture. It is actually quite sophisticated. Please come meet us at the stand if you'd like more details. But the way we kind of summarize it is for all the things going from supporting 50 different SQL dialects at the bottom, all the way up to this visualization layer. There's lots of individual capabilities you need to support all these different data experiences that you might want, from business intelligence through to custom apps. So a broad level, high level, the way to think about Looker is, in one sense, we're just an API for data. You've got a data warehouse. It's been populated via probably a number of pipelines, and now you need to describe that data, you need to give secure access to that data, and you want a single point to which you can go for the combined analytical data sets of your company. And then on top of that, actually unlimited data experiences, as we call it. Out of the box, we will give you modern self-service BI so that the front end is tied closely into the warehouse, but also all of those other use cases, workflows, custom apps, and so on, can be built out using either simple embedding, which is really fast, or API calls if you want to spend time building something custom. And with that, I believe I have just come up to time. So I hope you'll come to see us. We are actually here with our partners Fivetran and Snowflake for the full stack, data pipeline, data warehouse, data analytics. And I hope this talk was useful to you.